All right, number 15, we're looking at the number of home runs of Mark Gregor's hit in his first 13 years of his baseball career. So I want to construct a stem and leaf, and then I want to go back in and describe the data. So in this case, I'm looking at my numbers, and I think it's going to be easiest if I use the stem piece to be the tens digit and the leaf to be the ones. So I would have 0, 1, 2, 3, 4, 5, 6, and 7. And I want to set up a key real quick. So a good stem and leaf is going to have a key. And in this case, I want to say that 4, 9 represents 49 home runs. Let's see. And then I want to look, let's start with the ones digit. So the 3s and the 9s, starting with the smallest. So looks like 3, 9, 9. Let's cross those out. Let's see, anything in the ones? No. The 2s, 20s, I have 22. And then 30s, I have 32, 39. Okay, so it looks like I have at least 132, and then a 133, and then a 39, and another 39. 40s, I get a 9 there. And, oops, I got a 42 first. And then I got a 49. 52, and then an 8. And 70, I get a 70 right there. Okay, so that's my stem and leaf. And then I want to come in and sort of center, unusualness, shape, and spread. And again, this is based off my graph that I'm looking at this. I understand that we could just type our numbers in and get the exact estimate on this. But it looks like our center is going to be somewhere in the 30s. And I'm just going to go on the upper end and say it's around 39. So center is around 39. Now I guess I should have that conversation about mean versus median. This is a little bit more symmetrical. We have a big chunk of data between 20 and 50, and then I have a few numbers on either side of that big chunk. If anything, it's a little more skewed towards the lower end because of there's 3 observations at 3, 9, and 9. But generally kind of balances out. So we can say it's somewhere around where that big mound of data is, around 39 as our center. Now, unusual, we've actually got 2 gaps. We've got in the 10s there are gaps, in the 60s there are gaps. So there are 2 gaps at 10s and 60s. So he didn't really have he had, I guess starting off it was kind of low, and he had one really extreme year, and the rest of it sort of right there in the middle. Shape would be symmetrical. And then the spread, again, since we're not typing the numbers in the calculator to calculate standard deviation or IQR or anything like that, then we just want to end up with range. So range is 70 minus 3, or 63. Okay, so in number 16, we're given, let's see, the local police using radar check the speeds of 30 motorists in a construction area. Results are listed below. Construct a frequency distribution, relative frequency. Okay, so in this case, I think the numbers are big enough, and I want to be a little bit more accurate with my answer than the last time I did this. So I'm actually going to use technology to help check myself, if that makes sense. So I'm going to personally use Excel, or you can use a calculator, but I'm going to type all of these numbers in so that I can organize them and see a little bit better about how I want to set this up. And then we'll kind of check back and look at all these different answers that I'm supposed to come up with. So let me first pull up Excel. And I won't force you to watch me do all of this, but I'm just literally going to type in 30 numbers And so if you're doing a calculator, then you want to put it into your list 1, and then you want to go back in and sort that. So I'm going to pause the video so you don't have to watch me type in 30 numbers. Okay, so I got my numbers in, and kind of the only check that I have is that I typed in the last number and it stopped at 30. So that's kind of a subtle hint that maybe I did it right. Okay, and then the next thing I want to do is I want to sort this. So in Excel, that's actually not too bad. You just highlight the cell, go to data, and then just A to Z it, and it will put it automatically in order. And let's take a look at the questions then. So questions want a frequency distribution, a relative frequency, cumulative frequency, and a relative cumulative frequency using 6 classes. So let's start with what would make sense to have in our 6 classes. If my data goes all the way from 33 to 50, let's do this. So let's say 50 minus 33 is a difference of 17. And I want equally distributed among 6 classes. So I'm going to take that range divided by 17, and I get about 2.83. So I'm going to round up and say about 3. So if I start at the lowest number and add 3 each time, kind of do a class width here. So let's say my class width on the low end to the high end, so 33, and then I'm going to add 3 more to the next category, so that puts it at 36, and then 39, and then 42, 45, add 3 more, I get 48. Is that 6 so far? 1, 2, 3, 4, 5, 6. Okay. And so anything from 33, so on the high end, we want to go up to 36, not including 36 because that's in the next category. So we'll say 35.9. And this would be 38.9. As far as I'm saying, anything within that range, each number is only going to go in one spot. And there's the columns that I'm listing it in. Let's see, 39 all the way up to 41.9, up to 44.9, up to 47.9. And then this one I have to think if I added 3 more, I'd get 51, so 50.9. Okay, and then I'm just going to set up a nice chart. And in my chart, I need to have a frequency. I need to have a relative frequency. I need to have a cumulative frequency and a cumulative, relative cumulative frequency. Okay, so those are the 4 things that I'm looking to put in my chart. And make that a little bit bigger. And since this is Excel, I'm just going to throw some lines around this. Again, on the test, you would just copy a chart like this. Okay, so I need to just simply count for a second. And it's nice to have this organized. So anything from 33 up till just before 36. So I have 3 numbers there. And I can change the color so I can see that I've already taken those into account. All right, then I want 36, 37, and 38. So what is that? 1, 2, 3, 4, 5, 6. So another 6 here. Then I want 39 to 41. So 1, 2, 3, 4, 5, 6. Another 6. 42 to 44. 42 to 44 right there. 1, 2, 3, 4, 5, 6. I'm noticing a pattern here. Oh, 1, 2, 3, 4, 5, 6. Should have highlighted that to make it a little bit easier. And I want 45 to 47. 1, 2, 3. Okay, 3 of those. And then 48 to 50. So 3, 4, 5, 6. There's a 6 again. Okay, now if I did this right, this should add up to the total number of data, which is 30. So I can just do a quick sum and just confirm that. Okay, so that's what that is. That's frequency. Relative frequency, well, this would be the fraction form of that. So 3 out of what? 3 out of 30. So 3 out of 30 for that one. Ooh, it wants to think it's a date. So I'm just going to say, just put them all as numbers. And of course it went in and changed the number on me. Okay, so now it should let me do 3 divided by 30. And it actually gave me the decimal component of that, and that's fine. Okay, and then we have 6 divided by 30. Another 6 divided by, well, at this point we kind of know what the decimal form of it is. 3 divided by 30, and then 6 divided by 30. Okay, so those are all my relative frequencies. Cumulative frequency, so now we're not talking about relative anymore, we're talking about just cumulative. Cumulative means add as I go, so kind of look at your tallies, your frequencies, and add each successive cell up as we go down. So I start off with 3, then I add another 6 to get 9, then I add another 6 to get 15, and then I add another 6 to get another 15, then I add a 3 this time to get 24, and another 6 to get 30. Okay. And then last but not least, a relative cumulative frequency. So again, this is in fraction form here. So out of 30, so take this set of numbers, this frequency column, cumulative frequency column, and then just put that over the total number of observations. So 3 over 30. Again, it's changing the dates. All right, so let me just tell Excel. These are numbers, please. So 3 out of 30, 9 out of 30, 15 out of 30, 21 out of 30, 24 out of 30, and 30 out of 30. Okay, so those are my, what percent of the data has already occurred in each of my categories. Number 17, we're given a list of data and now asked to calculate some information about it, starting with the mean and standard deviation. So I want to, I'm just going to go to Excel. And again, you can do this in a calculator, and I'm going to just type in those numbers. So take a second to do this. And again, I don't really think you want to watch me type in my numbers. You want to type in your own numbers. So whether you're going to do this in Excel or do it in your calculator, type in your set of numbers and then join me when you're done. Okay, so I've got my numbers typed in, and for starters I need to calculate the mean and the standard deviation. So if you know your Excel function, you can do that route, in which case it's average. Or if you want to just type it in your calculator and use the one-var stat menu, that's also fine. Now, it helps if I spell it right. Okay, and then standard deviation. Now, again, we have to decide whether we're dealing with population or statistic. your calculator will generate both. We have a formula chart for both. Since we don't have any evidence that this is a sample, we're going to say that this is a population standard deviation. And again, unless you're given specifically that it is a sample, then you would assume it is a population. Just going to label this so I don't have to rewrite it. Okay, 5-number summary. So 5-number summary is I need a min, I need a max. I'm sorry, I'm doing this out of order. I need a Q1, a median, Q3, whoops, and a max. Now, if I order my numbers, I can quickly pick out 2 of these guys. So I can, and it really just ordered everything, didn't it? Let me undo that. Okay. Continue with current. Okay, so from there I can see that the minimum value is 64 and the maximum value is 74. Now I could have just looked at my numbers to see that, I get that, but okay. And then those that typed it in their calculator and got the 1var stat pretty much have all their information. We're going to do quartile. I'm going to highlight all my numbers, comma, and then I want the first quartile for that value. And then here I want the median. So highlight all of that. And then here I want Q3, so the 75th percentile. And if that menu doesn't pop up, you can just type in what percentile you're actually looking for. So Q3 is 75th. Okay, so that is that. So that's the information that I would copy over and put in the test under 5-number summary. Next question, would mean or median be an appropriate measure and why? Okay, so one thing I could do is I could look at the graph of this. The other thing I can do is I can just compare the mean and the median. If it's symmetrical data, the mean and median should be pretty close. And being at 69 and 70, I would say that that's pretty close to each other, so it's symmetrical data. In which case, the mean is the most appropriate measure because of the symmetry. Box plot. Okay, so this one, I do want to take a second and draw in some information here. So, before I get too excited about that, let's actually figure out if there's any outliers. So I need the IQR of my data. So interquartile range would be Q3 minus Q1. It's going to give me a number, and then I want 1.5 IQRs. So I want 1.5 times the number we just calculated. Okay, and then I want the lower fence and the upper fence. So the lower fence is take the Q1 and subtract off that number we just found of the 1.5 IQR. And the upper fence is to take the Q3 and add that number we just found. And so those two numbers would represent our upper and lower fence. And by looking at our numbers, I can see that we don't have any outliers because we wouldn't consider anything anything below 59 would be a lower outlier, and anything above 78 would be an upper. And our data goes from 64 to 74. So again, no outliers in this case. Okay, so as far as graphing it, let's see, I want min as at 64. And then Q1 is at 66.25. connect that. And median is at 70. Q3 is at 71. I got a little extreme on that when I drew that in there. That's a little bit closer, and these aren't even, wow. Good thing I teach math and not draw. All right, and then upper is 74. Okay, and then on the lower end we have two fences. We have one fence at 59.125. And we have another fence at 78.125. Okay, and no data outside that.